Hello friends, this video is created by Siddharth Upadhyay, founder and creator of PrepWings. Log on to www.prepwings.com for complete free course videos. Okay, in this video we'll talk about relative speed. So when we say a car is moving at a speed of 60 km per hour, it actually means that the speed of car is with respect to the ground or relative to the ground. Okay. Generally, when we mention speed of a body, it is with respect to the ground, so we do not mention it explicitly. Okay. Relative speed actually means the speed of a body with respect to another body. Alright. So when two bodies are moving, we can find the relative speed of one body with respect to the other body. Okay. In our case, we will just be limiting our discussion to when the bodies are moving in the same direction or when the bodies are moving in the opposite direction. Okay. Okay. So now here we'll look at the first case. It says when two bodies move in opposite direction. Now suppose car A and car B are moving towards each other. Okay, moving towards each other means moving in opposite direction. Car A is moving at 40 km per hour and car B is moving at 60 km per hour. Suppose we have to find car B's speed relative to car A's speed. Okay, so we will follow the steps given. Step 1 says make car A to be static. Okay, so basically assume that car A is not moving. In step 2, add car A's speed to car B's speed to get the relative speed of car B. Okay. Thus, the relative speed of car B with respect to car A will be equal to car B speed plus car A speed. Okay. And car B speed is 60 and car A speed is 40. So when I add them, I get 100 km per hour. So the relative speed of car B with respect to car A is 100 km per hour. Okay. But for that to happen, I have to assume that car A is static. Okay. Static means it's not moving. Okay. Now we look at the second case when two bodies move in the same direction. Now suppose car A and car B are moving in the same direction. Car A is moving at 40 km per hour and car B is moving at 60 km per hour. Now over here again we'll have to find car B's relative speed with car A. Okay. The bodies are moving in the same direction over here. So step 1 is same as before. Step 1 says make car A to be static. So assume that the car A is not moving. In step 2, subtract car A's speed by car B's speed to get the relative speed of car B. Okay. So relative speed of car B will be equal to car B's speed minus car A's speed, which is 60 minus 40, 20, which is equal to 20 km per hour. Okay. So the relative speed of car B with respect to car A is 20 km per hour. Okay. Okay, now we'll be doing a few questions. Now over here, the question given states two cars move towards each other at speeds 20 km per hour and 30 km per hour. Find the time it takes the cars to meet if the cars are 100 km apart. Okay. So here the cars are moving towards each other. Thus the relative speed of one car with respect to another is 50 km per hour. Okay. And the distance is 100. So applying the formula time equal to distance upon speed. Okay, because the fundamental formula of time speed distance is equal to speed into time. So time will be distance upon speed. Okay, distance is 100 km and relative speed is 50 km per hour. So if we divide distance upon speed, we get time as 2 hours. Okay, thus it will take 2 hours for the cars to meet. Now this question says car A moving at 30 km per hour is chasing car B moving at 20 km per hour. The cars are 100 km apart. Find the time it takes car A to catch up with car B. Again, the cars are moving in the same direction. Thus, relative speed of one car with respect to another is 30 minus 20, which is 10 km per hour. And the distance is 100 km between them. So, to calculate time, we'll use the formula time equal to distance upon speed. So, distance is 100, speed is 10. So, 100 upon 10 is 10 hours. Thus, it will take 10 hours for car A to catch up with car B. Okay. Now, over here, the question states two trains are moving towards each other on parallel tracks. The trains are 39 km apart. Each train is 500 meter in length. One of the train is traveling at a speed of 40 km per hour and the other at a speed of 60 km per hour. Find the time taken for the trains to cross each other. Now the scenario is shown here. There is train 1 traveling at 60 km per hour and train 2 traveling at 40 km per hour. The distance between them is 39 km and each train is 500 meter in length. Okay. So what we can do is we can assume train 2 to be static. Then train 1 will have to travel a distance of 39 km plus the length of train 2 plus the length of train 1 for train 1 to completely pass train 2. Okay. Now assume train 2 be stationary. Relative speed of train 1 with respect to train 2 is 60 plus 40 km per hour, which is 100 km per hour because the trains are moving towards each other. Now as we discussed before, train 1 will have to travel 40 kilometers to completely cross train 2 because 39 kilometers is the distance between them. So train 1 will be traveling 39 kilometers plus 0.5 and 0.5 because each train is 500 meters in length. Okay, so the distance traveled in this relative scenario is 40 kilometers. The relative speed is 100 km per hour. So applying the formula time equal to distance upon speed, we get time equal to 0.4 hours, which is 24 minutes. Thus it takes 24 minutes for the trains to completely cross each other. Okay, so this is all about relative speed. Thanks a lot for watching this video.